Hello viewers, this is Professor Dr.Mchem from Dr.Mchem Institute of Chemistry, University of St. Jamshoro. Today I was discussing with you the unit cell, crystal lattice and crystal systems. So I thought I must share a few slides to make you see visibly what actually happens when we describe a unit cell. First of all, we have in a list in which we have the unit cell number 1, then the crystal lattice and crystal systems. So I'll start with the unit cell. Now, what is a unit cell? It's the repeating unit of a lattice is a unit cell. It repeats itself to form a crystal. Now here you can see a unit cell, right? Now it has got some edges like A, B and C, and with angles like alpha, beta and gamma between them. Now unit cells are further subdivided into primitive and centered. So now, as I just mentioned, that unit cell is of two types, that is primitive unit cell and centered. So when the particles are present at corners of a unit cell, it is called primitive unit cell. Now here you can see the corners, they are present here. Whereas when the particles are present at the random positions on the corners, it is called centered unit cell. These are the other positions, right? So now the centered is further divided into three types, that is body centered, face centered and end centered. The body centered unit cell is based on the elemental or basic particles presence at the body center with the corners. This is called body centered unit cell. Whereas number 2, the face centered, here you can see this is a 6-face centered unit cell. The face centered unit cell is based on the elemental or basic particles presence at the 6-face centers with corners. So 6-face centers with the corners, right? These are the 6-face centered unit cell. This is the 3D figure of a body-centered unit cell, whereas this is the 6-face centered unit cell. Number 3, the end-centered. The end-centered unit cells are based on elemental or basic particles present at the corners of two of any opposite faces with the corners. So this is called end-centered unit cell. These are the centers, you can see centers of opposite faces. Crystal systems. Almost 230 forms of the crystals are there. These are further divided into 32 more classes in accordance with the symmetry and are then again classified into 7 more crystal systems relying on ABC, that is the crystallographic framework, which I just explained in my previous lecture, that these are A, B and C are the crystallographic framework having angles between them alpha, beta and gamma. Now here you can see the 7 different more crystal systems, right? Now this is the cubic one you can see here, and then the tetragonal, orthorhombic, hexagonal, triclinic, monoclinic and rhombohedral. Now the cubic, it has got, you can see the angles alpha, beta and gamma here, right? And where you can see that alpha equals to 90, beta 90, gamma 90, whereas in this tetragonal again you can see the angles between the crystal system alpha, beta and gamma having 90 degrees angle. And this is the orthorhombic, in which you can see the angle between this side and this side equals to 90 degrees, that is alpha, beta and gamma. Here again hexagonal, you can see this different angles, that is alpha, beta and gamma. Again in rhombohedral, the alpha angles are shown here as A is equals to B and C is equals to A, that is this side equals to A and B is equals to A. Now here again in the monoclinic type, you can see the 3 different angles, that is alpha, beta and gamma having right angles, that is 90 degrees between them. And then the triclinic, in the last That is the last of the 7 crystal systems. This is the last form, and you can see here again the A, B, and C having angles alpha, beta, and gamma between them, all 90 degrees. So this was something about the crystal systems. I took this knowledge from, I can refer it to www.7activin. It's a very interesting site, and I would refer all my students and viewers to go through this site, to go through into, deeply into the crystal forms, crystal systems, and it's all about crystallographic history and the modern knowledge and the most advanced knowledge about the crystallographic framework is available there. So I found this very interesting, and I thought I should explain all these beautiful crystal systems in my own handwriting, with my own handwriting, and these are all my own drawings. I've drawn them with great difficulty, because when you are showing the three-dimensional system, it's difficult to draw the 3D structures, but I tried my level best to draw them, and I hope you will like it and you will enjoy reading these forms. And inshallah, I will, in my next lecture, hopefully I will explain you the other forms also, and I will explain these one also in details, as they have some other details too, which are very interesting to share. So I hope you like this video. Please share, enjoy, and learn more and more. It's more to learn instead of sharing something knowledgeable is good. So in that sense you can share it. Otherwise, just learn for your own knowledge. You should know how the crystal, what is the geometry inside crystal. This is now all interrelated. The chemistry, physics, this is all interrelated. So you will find this topic in physics lectures also, and it has something to do with that also. So I hope you will enjoy learning all these drawings, and you can see these drawings with a little more clarity, like this. If I make it a little bit closer, you can see them. They are very interesting, and I've made them with real hard work for you people. So hope you will like these drawings, and you will be able to draw these structures. Please learn to draw them, because in exams maybe you can be asked to draw the structures. So it's better to learn now instead of before it's too late. Thank you so much. See you in my next video. So students, I would like to go through or summarize the things which I've explained you in my previous lecture, or in the start of this lecture. That is, we first discussed about the unit cell, and we just saw that it's a repeating unit of a lattice, and it is simply it repeats itself to form a crystal. And then I showed you the crystal structure, the 3D structures, having unit cell having edges like A, B, C with their angles alpha, beta, and gamma between them. Then I showed you what is crystal lattice. It is simply a three-dimensional array of atoms or ordered atoms or particles as different points in space, you can say, or separation between the layers describes a lattice, right? So somebody can ask you what is a lattice. You can tell them that it is simply the separation between the layers. And then I show you the 14 different lattices that were called Bravais lattice. And Bravais lattice he was a French mathematician who formed all these lattices, and he helped us to know about these beautiful forms. So it was divided into cubic lattice, tetragonal, orthorhombic lattice, monoclinic, and etc. Then I explained you about the types of the unit cell, that is primitive and centered. Then when particles are present at corners of a unit cell, it is primitive, whereas when particles are present at random positions, they are on the corners, they are called centered. And the centered is further divided into face-centered, body-centered, and end-centered unit cells. So then I ended this topic with the crystal systems that almost you can say 230 forms of the crystals are there, and further they are subdivided into 32 more interesting classes, and that those classes are depending upon their accordance with the symmetry. That is how the symmetry is describing them, and are then further they are classified or divided into 7 more crystal systems, relying on what? On the crystallographic framework, that is having angles alpha, beta and gamma between them, right? And what was the crystallographic framework? That is the ABC. That was the crystallographic framework having angles alpha, beta and gamma. So now we have learned about the crystal systems, that there are 7 more different types, and I've shown you with the drawings also. These were the different drawings which I just showed you here, right? So these are beautiful and they are very interesting. These are all subdivided into cubic, tetragonal, orthorhombic, hexagonal, rhombohedric, hedral, triclinic and monoclinic. So having different angles, that is alpha, beta and gamma between them, right? Having 90 degrees angle. So I hope you find all these short topics, I described them shortly, but you can go into the details and you can learn more as you have time now, and you have the reference. I gave you the reference. It's a www.7.active.in. You can go and refer to this website, and you can go through all the crystallography over there, and you will come across other physicists also who are explaining in this field, because when the physicist describes the crystal systems, it's something very different from a chemist. I'm a chemist, so I can explain few things, but not with that perfection as a physicist can explain to you. So please go through that site also. That will also help you out in getting knowledge about crystallography, as you are now jumping into the next section of XRD analysis, and where the XRD is only applied on crystals, because it never goes for any other substance rather than crystals. So it was very important to know about the nature of the crystals. That's why I found this topic very interesting, and I thought that it is directly related to X-ray diffraction, which I was explaining you previously. So I thought that I must go through this crystal system first, so that you should know what are crystal systems, how many types are there, and you should know what is diffraction. There are particular terms which you should be knowing before jumping into the Bragg's law, which inshallah, hopefully, I will be explaining it to you in a nice way. See you. Have a nice day.